This video is going to be on assigning oxidation numbers. But first, we should probably understand what this number is. An atom's oxidation number is the charge that atom would have if all the valence electrons in a molecule were completely transferred, like they are in ionic compounds. That means that the charge doesn't actually belong to that atom. It's just a bookkeeping method for keeping track of electrons as they transfer in redox reactions. There are a few simple rules that we need to know about assigning oxidation numbers before we get started. Rule number 1. Free elements have 0 as their number. That means that elements like copper or hydrogen or fluorine all have an assigned oxidation number of 0. Rule number 2. For ions with only one atom, their oxidation number is the charge. For example, if we had copper 2+, the oxidation number would be 2. For iron 3+, the oxidation number would be 3. For the oxide ion, the number would be -2. Rule number 3. The oxidation number of oxygen is -2 unless it is a peroxide. For example, if we have a compound like magnesium oxide, the oxidation number of the oxygen is -2. Another example is water. In water, the oxygen atom has an oxidation number of -2. However, for peroxides like potassium peroxide or hydrogen peroxide, the oxidation number for oxygen is -1 instead. Rule number 4. The oxidation number of hydrogen is +1 unless bonded to a metal. For example, in water, we already know the oxidation number of oxygen is -2, and the hydrogen in this case is +1. If the hydrogen is connected to a metal, like in lithium hydride, the lithium will maintain its ion charge of +1, and the hydrogen will be -1 to counter it. Rule number 5. Fluorine's oxidation number is always -1 in a compound. We could take hydrogen fluoride or hydrofluoric acid if it's dissolved in water. The hydrogen in this case is +1 and the fluorine is -1. Or we could have a slightly more complicated compound like sulfur tetrafluoride. In this case, the fluorine is -1 and the sulfur is +4. Rule number 6. In a neutral molecule, the sum of oxidation numbers is 0. For example, sulfuric acid. Now, I may not know sulfur's oxidation number off the top of my head, but I do know hydrogen and oxygen. Oxygen is -2 in all cases except peroxides, and hydrogen is always +1 unless it's with a metal. That gives me a little bit of an algebraic equation to play with. I have 2 +1s, a mystery number, and 4 -2s. All of these oxidation numbers need to add up to 0. So now when I simplify, I have +2 plus a mystery number plus -8. And if I simplify my expression, I'll end up with my mystery number being +6. That means sulfur's oxidation number is +6 in this case. Rule number 7. Oxidation numbers don't have to be integers. For example, in the polyatomic ion I3-1, you can see that each one of my atoms must add up to a total charge of -1. This makes it so that each iodine has an oxidation number of -1/3. Okay, let's go over a few examples. Okay, our first example, the lithium oxide, isn't too bad. Oxygen is always -2. And even if I didn't remember that lithium ions are always +1, I could use a trick where I have two mystery numbers plus -2 times 2 oxygens equals 0, which is my overall charge on my species. This would make it so that my mystery number is equal to +1. In the nitric acid, we can see that oxygen is -2 and that hydrogen is +1 because it's not next to any metals. And then we can do some math to figure out the nitrogen. So we have a +1 charge and there's only one hydrogen plus a mystery plus -2 times 3, and there's no charge on that species, so it will equal 0. Okay, so we'll have 1 plus x minus 6 equals 0. This means that nitrogen's oxidation number is +5. Okay, last one. So, I see that we have an oxygen friend again, and our oxygen is not a peroxide, so he's -2. And we have an overall charge of -2, so that's interesting. And we have 2 chromium atoms. Okay, so we'll have 2 mystery charges plus -2 times 7 equals -2. So if I simplify this, we'll have 2x minus 14 equals -2. When I add over the 14, we end up with 2x equals +12. Divide over the 2, and we'll see that our x is equal to +6. That means that the oxidation number of the chromium in this case is +6. Now we need to move on to how we use oxidation numbers to balance oxidation-reduction reactions.